Guys, we're not going to spend a lot of time on the do now. You guys know how this works, but I do want to point something out. I added fractions into problem number 2 or into level number 2. You guys have shown me that we have some trouble with fractions. My job as a teacher is to take your unit test over and over and over again throughout a chapter to remind myself of what the test is going to look like, Christian. And then I give you as much practice as I can with problems that are the same difficulty as the test. That is a hint. Let's focus on problems number 1, 2, and 3 first. You should have noticed something weird with number 3. After I distribute, I get -3 and 3. Those are 0 pairs. I get -15 and 15. Those are 0 pairs. I put some question marks here. What do you guys think that answer means? 2. Marco, what do you think?
It's the infinite solution.
Disagree. There's no equal sign.
Oh. No.
Any other thoughts?
Wait.
Let me say it again. After I distributed, I was left with this expression. I combined like terms, and they were all 0 pairs. What do you guys think the answer is in that situation? Katara?
Oh, I have a question.
Let me focus on my question, and then I'll look at yours. I hear people whose hands are raised. Yadel, what do you think? The answer is 0. Be really careful. I did see one person today that wrote x equals 0. If you're saying x equals 0, then you're telling me that this is an equation, and you solved it, and you got the answer at 0. It's not true. This is an expression. When we simplify it, they're all 0 pairs. The answer here is 0. Yes, ma'am.
So how'd you get 4x? Because I got 1x.
Show me where? On number 2?
Yeah.
Well, there are a couple ways you could go about it. I did 3 and -5. That's -2. 6 and -8. That's also -2. And when I combine -2 and -2, that gives me -4. Last question, Springer?
Oh, understand the second one.
I think that's the same question that Kateri just asked. Are you getting lost in the distributive property?
No, like the last one. Like,
with -4?
level 2.
Oh, down here. Thank you. Guys, we are not going to go over this question now. That's not the focus. My focus is to give you as much practice as possible with stuff that you're going to see on the test, and this is very similar to the type of difficulty you'll see on the test. I was asked to multiply fractions. I showed you all my fraction multiplication over here. 1/4 times 12 is 1/4 times 12, which gives me 12 over 4, which is 3.
Oh.
If you are struggling with fractions, we'll continue practicing there, but now is not the time for that.
Okay.
We're going to stop with the do now. We're ready to move into our lesson today. Really quickly, I want to frame where we are today. Amir, can you sit up for me, please? Guys, we started talking about one, no, and infinite solutions last week. Today is our very last day. We are moving one step higher from where we've been. We're no longer solving equations that are given to us. Today, Christian, can you show me you're listening? Today, you guys are going to be taking everything that we've learned and putting it together. You're going to be creating your own equations. This is probably as high. This is probably as high a level as we'll see with this. You're going to make your own equations based on what we know about the structure of equations. I'm going to get you started on your own. If you can turn your roadmap and find the Think About It section. Guys, the theme for today is going to be practice. I don't think you need a lot of direct instruction from me. We've talked about what a one solution equation looks like, what a no solution looks like, what an infinite solution looks like. Today you're going to be putting it all together on your own. Can somebody read at the top where it says write an equation? Fatima, go ahead.
Write an equation that has at least 2 terms on each side that will result in an equation with no solutions.
Okay, you are going to write your own equation. There need to be at least 2 terms on the left and 2 terms on the right. The answer should be no solutions. You're going to tell me how you got that equation. Here, I should see the words coefficient and constant. Those words are on the board if you don't know how to spell them. For number 3, for the stretch it question, how could you change this to make it have one solution? I'm going to give you guys 4 minutes here to practice by yourself. I'm gonna be looking for a couple people's work. I'm looking for the most difficult equations that I can find, and we'll show those off in front of the class. Any questions before we get started? You have 4 minutes. Your time starts now. Working. Pick up your pencil. Put it on the paper. As soon as I see that, I can come around. Ethan, waiting for you. No, I'm waiting for you. Get started. As I'll say it again, you should be using the resources that you see on the board to build an equation that has one solution. Look at my example and make one simple. Sorry, no solution. Guys, I'm already seeing some people with correct equations. The next step is to focus on your explanation.
Oh, I got it, Mr.
Come and spring our seat. This is exactly right. Why did you write it like that? Okay, so let's use some vocabulary. Tell me about the coefficients. And tell me about the constants. Coefficients are what? They are what?
3x and 3x.
They're the same, right?
Yeah.
What about the constants?
They're the one that's different.
That's what I should see in your explanation. The equations are good. We're missing the explanation. This is where we need to focus. See, let's bring it back. Guys, these are the trends that I saw. You guys are able to explain to me mathematically. You're able to show me the equation, and for the most part, about 75% of us have the correct equation. The writing is where we're struggling a little bit. I know you guys don't like to write as much. That's really going to be a heavy emphasis for today. The key here is, as you're explaining, I should see something about the coefficients. You're telling me whether they're the same or different. I should see something about the constants. You're telling me whether they're the same or different. I'm going to put up Daniel's. Daniel has a perfect equation. He included distributive property, which it didn't say we have to do, but we are going to see that later today. He's missing an explanation. So first of all, do you guys agree that this has no solution? Let's take a quick vote. I'll give you a second to look at it. You should be checking to see if his distributive property is correct. Then you're looking at the coefficients. Then you're looking at the constants. Raise your hand if you disagree that this is not a no solution equation. Raise your hand if you agree. This is a no solution equation. Thank you to my 8 people that voted. Raise your hand if you didn't vote. Guys, we need to focus on 100%. When I ask for a vote, get an opinion and be ready to answer. Daniel, you want to take a stab at what your explanation could be here? Sometimes people speak better than they write. What is the same and what is different? You can say it in Spanish also. That's okay. Let's look at Josh's, because Josh had a good example. Josh's equation is correct. His coefficients match. His constants are different. He went as far as to say, as I looked at Mr. Halfacre's example, I followed the rule. I know that the coefficients have to be the same and the constants have to be different. Where are we? Yes, I get this. I'm ready to practice. I need a couple more examples. What is a coefficient? Yes, I get this. I'm ready to practice. Or sorry, yes, I get this. I don't need to practice. I need a little bit of practice today. What is a coefficient? Cool. Guys, we're going to write down our key point, and then we're going to move to a couple quick guided examples. Thank you.